In this video, we'll talk about a specific type of discrete random variable called a binomial random variable. A binomial probability distribution is a probability distribution that meets all 5 of the following requirements. The procedure has a fixed number of trials. There are only 2 possible outcomes for each trial, and we label these as success and failure. The probability of success remains the same in all trials. The trials must be independent, and the random variable is the number of successes. Notice this is called a binomial random variable, bi meaning 2, because there are only 2 possible outcomes. It turns out that our 3 coins example is not only a discrete random variable, it's also a binomial random variable. Let's look at the definition. We're going to flip the coin 3 times, so that's a fixed number of trials. There are only 2 possible outcomes for each trial, and since we're counting the number of heads, we'll count heads as a success and tails as a failure. We have a probability of success of 1/2 because it's a fair coin, so it's the same for all trials. And all the trials are independent because we're tossing a coin, and the coin doesn't remember what happened last time. And we've set up the random variable to count the number of successes. We know the probabilities already. Is there a way to figure out the probabilities without writing out the sample space? In fact, the answer is yes. We can use our counting techniques. In how many ways can we choose 0 of the coins to be heads out of 3 heads? That's a combination, so we have 3 heads choose 0, and there's only one way to do that. How many ways can we choose 1 head out of 3 coins? There are 3 ways to do that. How many ways can we choose 2 heads? 3 ways again, and just 1 way to choose all 3 coins to be heads. Because we have a fair coin, all the events in the sample space have an equal chance, and we can use that to find the probabilities. Now let's suppose I have one of my brother's weighted coins, and this coin has a probability of 80% of landing on heads. I'm going to flip this coin 3 times and count the number of heads. Is this a binomial distribution? Yes, it is. We still have a fixed number of trials. We still have only 2 outcomes. The trials are still independent, and the probability doesn't change between trials. For all the trials, the probability of success is 0.8. So this is a binomial distribution. What is the probability of exactly 2 heads? Again, I can find the number of ways that can happen by using the combination of 3 things choosing 2. But now that all the outcomes aren't equally likely, we need to find a way to find the probability of 2 heads and 1 tail, and that's the multiplication rule. So we use that to multiply 0.8 times 0.8 times 0.2. This leads me into our general formula for the binomial distribution. Here's our general formula. This is one way we can use to find probabilities, and we'll discuss some other ways in a little bit. But using the formula for my example with the weighted coin, to get the probability of 2 heads and 3 flips of a coin, with the formula, I get 0.384. In fact, there are 2 other ways to get the probabilities, and using the formula is my least favorite way. One way is to look at probabilities from the binomial table in the back of your book. Now, you might think I like tables just because I'm old-fashioned, and when I was in college, we didn't have fancy calculator functions. We had to use the table. So there is a little bit of nostalgia toward the tables, I confess, but it's still a really simple way to get binomial probabilities. And as I alluded to slightly, we also have a calculator function that a lot of my students like. So if you really want to use the formula will work. And in fact, the formula is how they got the numbers for the binomial tables and how the calculator computes the probabilities. So how do we use the table? First, we look up n in the table. So we find n equal to 3, And then we'll see a column for x's, either 0, 1, 2, or 3, because those are the possible values, all the possible values for x. We look at the column for a probability of 0.8, because we're talking about our weighted coin. That's the probability of a success. And then we can see the probability of 2 heads, so that's x equal to 2, out of 3 flips, n equal to 3, on that weighted coin is 0.384, and that's the same probability we got with the formula. Here are the instructions for the calculator codes in the TI-8384. If you have a stat wizard on your calculator, it will ask for n, p, and x. Otherwise, you will need to enter them, and they're always in alphabetical order. So on a TI, you hit second vars to get to the distributions. You'll arrow down to get to binom PDF, and then enter n, p, x. If you enter just the n and the p, this gives you the probabilities for all the values of x. And we will practice these calculator functions in class. One of the very best things about binomial distributions is that it simplifies the formulas for the mean and standard deviation. For any binomial distribution, the formulas we learned back in section 6.1 will simplify to these formulas, which are so much easier to calculate. So what about our example? If we flip that weighted coin 3 times, and we do it over and over, thousands of times, out of 3 flips, how many heads will we get on average? The mean is n times p, so we have 3 times 0.8, which is 2.4. And the standard deviation is 0.69. And that's how it works. We'll practice this more in class, and you will see why binomial distributions are so cool.